Hey there, this is Khader and Electronics. It's been a while I posted any video because of many problems running in my life, and I took lots of time overcoming them and making myself mentally stable. So that is the reason I couldn't post any videos from last maybe 2-3 months. I'm really sorry for that. I hope I'll make up the videos which I missed and the time which I delayed, and probably make sure I don't repeat that in future. So without wasting much time, let's start today's video, that is about resistors. This is one more E-basics video. Let's see. So resistors are like speed breakers of current. Say for example, there's a road where 100 vehicles are traveling at a speed of maybe 100 kilometers per hour. And what we can do to reduce the speed of these vehicles? We can place some speed breakers there, which would reduce the speed of the vehicles, because once the vehicles come there, they'll automatically slow down. A similar example is of resistor. Say for example, there is a conductor where current is traveling at a current of 1 amp maybe. So this 1 amp current, when we want to limit the current or we want to reduce the current, we can add a resistor there. And yeah, resistor is shown with this symbol. This is the exact form of a symbol which would represent it's a resistor. And in my previous one of the previous videos where I showed about potentiometer, the same resistor symbol is shown with the arrow, which tells a potentiometer. But if you remove this arrow, yeah, when you remove this arrow, it will be a resistor. So resistor is something which resists the current flow through it. And one of the important things which we should take care about the resistor is the resistance value, 1, and the power rating. So power rating varies. Power rating of resistor will vary based on our need and our circuit. Say for example, there is a circuit operating at around 110 volt or 110 watt power, or maybe 1/4 watt power, then there's no use of using a resistor in between this circuit, where resistor of around 10 watt or 1 watt, which is of no use. You can go through with resistor which is of power rating 1/4 watt or 110 watt, and it will do exactly what it needs to do there. But in cases where there's a power usage in the circuit of maybe more than a watt, more than 5 watts, or more than 10 watts, then there's absolutely a need of using a resistor of higher power. If not, what will happen is, say for example, there's some circuit, say a sample circuit like this, and something like this where a battery is charging or something like that, and there's a current flow of 1 amp. And the voltage across here is 5 volt, so that will be a power of approximately 5 watt, you can say, or the whole current power rating is 5 watt, for whole circuit power rating is 5 watt. In that case, if you use a resistor here of 1/4 watt, simply as soon as you switch on, maybe it might function for maybe 10 seconds, 15 seconds normally. After that, automatically this resistor will burn out and the whole circuit will be it can be shorted or open circuited, but most of the cases it will be open circuited. This is what I observed. And if it's a potentiometer, definitely it will be open circuited, but if it's a resistor, most of the cases when a resistor burns out, it will be open circuited. So this is the case. For this reason, you have to use the exact power rating of the resistor should be similar to what you use with the what is the power rating of your circuit. Next, coming to the resistance value. So the resistance of a resistor is decided based on the color coding of the resistor. So few of the colors which generally we use is black, brown. So black represents a 0 and brown represents a 1, and then comes red, which represents 2, then it's orange, which represents 3, and I guess that's yellow with 4. Green is 5, is 6, and then comes violet, which is 7, then gray is 8, and this white is 9. So these are the numbers you should be remembering to identify what is the resistance of a resistor based on its color code. So if you know these values, you can make out you can calculate what is the resistance of the resistor. So say for example, I have a resistor here with color coding starting from brown, then comes black, and say green. I'll take these three for sample. So that will be brown is 1. So first digit will be the value, exact value 1. The next black will tell you here the next value. So black is 0. I'll place 0 here. And then the third band will tell you the 10 power value. So green is 5. So it will be 10 power 5. So this will be 10 into 10 power 5. So that will be like 10 power 6. That is like 1 mega. 1 mega. This is like 10 power 6 ohm, as we saw here. Similarly, say there's I just put brown, then I would say red and orange. Can you tell what is the value here? Maybe. So brown is 1, red is 2, and orange will be 3. So that will be 10 power 3. So this is like 12 kilo ohm. That is 12 into 10 power 3 ohms. Similarly, there is yellow, violet, and orange. It will be yellow is 4 and violet is 7. So 47 into orange is 10 power 3. So that will be 47 kilo. Like this, you can tell what is the value of a resistor simply. And apart from these three, there will be one more band which will either be silver or gold. This is called a tolerance band. So the tolerance of this one will be plus or minus 10%, and this I guess will be plus or minus 5%. So these mostly, if you are just starting to learn electronics, then these values you mostly won't consider. So actually I never considered when I learned initially. So this you can just avoid. So these are the basic colors which you should remember to tell what is the color resistance of a resistor based on its color coding. So next would be how should you construct the value of resistor you want if you don't have one. Say for example, you are using a circuit where it calls for a 10 kilo ohm resistor. 10 kilo ohm resistor, but you have two 5 kilo ohm resistors. What would you do to get 10 kilo ohm? You just add them in series. Simple. Resistors add in series. In parallel, they would divide and multiply. So these are just reverse of capacitors. So in capacitors, when you have two in series, they would divide, and two in parallel they would add. The same way, resistors 2 in series will add, and 2 in parallel will divide. So let's see how we get here. So 2 into 5 kilo ohm, when you keep it like this will be 10 kilo ohm resistor. 10 kilo ohm which you want here. Or you want a 2.5 kilo ohm when you have two 5 kilo ohms. So the same way you will add them in parallel. So 2.5 and 2.5, I'm sorry, 5 and 5. So the 5 and 5, so 1 by 5 plus 1 by 5. They divide. So this will be 5 plus 2, and you put inverse of this one, this will be 2.5 kilo ohms. Inverse of this one. So 5 by 2 will be 2.5 kilo ohms. This is how you get the values of the required resistance. So no matter if you put it in series or parallel, the power will always add. Say for example, if you have two 1/4 watt 5 kilo ohm resistors and you add them, it will become half watt of 10 kilo ohm resistor. How? So power will calculate based on current into voltage. So this is voltage and this is current. So say for example, here the voltage will divide and the voltage will divide here. So the power across each resistor will divide. Current will be same as both of them are in series. So current flowing will be, say it's 1 amp here, it will be 1 amp there also, for this one also. But voltage will divide because they are in series. so power will divide, and if you are using two 1/4 watt resistors, it will be like you are using a single half watt resistor. The same applies to here also. Say for example, there are two resistors in parallel, each of 5 kilo ohm, and I'm applying a 1 amp current of 5 volts maybe. Okay, so 5 volts, 1 amp I'm applying here. What will happen? The voltage will be same across both the resistors. Then where is power divided? But the current flowing through both the resistors will divide. So because both the resistors are same, it will be half amp here and half amp here. So what's happening is, again the power is dividing across each resistor, and if you're using 1 watt power, then it will be half watt here and half watt there. So it will be like the total, if you're using 1/4 watt resistor, it will be a half watt resistor when you're using two resistors in parallel. So say for example, let's take one more example for the same. Your circuit asks for a 10 watt 10 kilo ohm resistor. So 10 watt 10 kilo ohm resistor. You have one 10 kilo ohm resistor which is of 1 watt, or you have 10 1 kilo ohm resistors which are of 1 watt. Which one do you think you should use for this value? If you use 10 kilo ohm 1 watt resistor and if give 10 watts power there, definitely this will burn out the second you put it there and switch on the cell. So this is out of the scope. You cannot use that there. But if you consider here, so it's 10 into 1 kilo ohm resistors, so you'll put all of them in series. So what will happen? The power will divide. Yes, so power will divide, and if you use 10 1 kilo ohm resistors in series, it will be 10 watt 10 kilo ohm resistor, exactly what you want, and your resistor won't burn out, it will be safe. So this is how you get the resistor value, power value and the resistance value based on different permutations and combinations of the resistors which you already have. And of course, even if you want decimal values also, you can construct in the base the same way, and you can get the values. Just in case if you don't know how to calculate the resistance, you can always use a multimeter in the resistance mode and put it across the two terminals of the resistor and tell you the resistance value. So as I have finished this, let's see how a resistor is actually constructed. There are different types of resistors. There's carbon resistors. This will usually be in black color inside. When you break the resistor, then you see a black carbon resistors. There will be ceramic resistors. There will be wire wound resistors. And there will be fused resistors as well. So wire wound and fused mostly be of high power resistors, and wire wound, I guess the initially starts with 2 watt or 1 watt, and they can go up to 10 watt, 15, 20 watt as well. Same for fused as well, even they go up to very high values. Ceramic and carbon resistors, they go up to 2 watt, 3 watt, 5 watt. I guess I have seen until 5 watt resistor for ceramic, but I am not sure. I don't think there will be a higher values. But wire wound on the other case will have a higher values. And if you see in the old times, we had this table fans or ceiling fans with the regulator, big top regulators, and these regulators had a resistor inside. And this resistor would be like a ceramic tube, like this, probably red color, black color, green color. They'll be completely ceramic, and there will be only few points on that. So wherever the regulator touches, that resistance value will be taken to send the current to the fan. And if it's higher resistance, then the fan will turn slower, and if it's lower resistance, the fan will turn faster. So what this will consist of is a thin wire wound around this ceramic, and at different points of this wire will be taking this connection. So what will happen there is the resistance of this wire is taken there, and this resistance is used in a circuit or a regulator or whatever is there. Ceramic on the other case would be this will completely be a ceramic tube or a ceramic small piece around on which there will be two terminals soldered or line caps. Usually the resistors which we see, the small ones, they will be in a shape like this. So there's a specific reason why the shape is like this. The resistor is constructed as a single tube first. So this is a tube of the material, say carbon or ceramic or whatever is there. This will be the material. It will be like this. And next what will happen is they will be taking two cups which are a little bigger than this piece. And these two cups will have the terminals attached, say the wire. So what will happen is they'll cover this piece with this cup. They're placing these two cups on the two sides of this tube, which will form a resistor. So the resistor will be like this. If it goes inside, it doesn't increase. I'm just saying that they will close the cups from both the sides to the tube, and this will be the resistor. And this on the top is covered with paints, ceramic or whatever, and they'll cover it, and then they'll put the coating of the resistor on top of it, so that we can identify the resistance of the valve. Resistance of the resistor. So yeah, so that is the reason why the shape of resistor is like this and not completely like a cylinder. And there are other resistors as well, which you call assembly resistors or surface mount type resistors. So these will be very small, and the coating will almost be the same on them. And this is mostly the construction of resistors. So based on your need, based on the value, based on the power which you are going for, you can choose different types of resistors here. And mostly I use ceramic, carbon and wire bond. Fuse I have never used much in my circuits ever, but I have few lying around in my table, but I never mostly prefer them. But wire bond on the other hand, yes, I use them. And the advantage of wire bond is it usually heat up and they don't burn out so fast. If even if the power used is on the edge of the rating of the resistor. So that's all for today's basic video for resistors. Let me know how you like about this video. If you like this video, you can give a thumbs up. You can subscribe to my channel for my latest videos and click on the bell button to get updates whenever I post a new video. And if you have any doubts, you can just post them in the comments. I'll read them. I'll reply to them as soon as possible. And that's all for today. Thank you, and I'll see you in the next video.